Hello and welcome to a discussion about Lab 2. So this is the online discussion for Lab 2. And what I want to do is I want to walk through Lab 2 and talk about what Lab 2 is and what you're going to learn, the learning outcomes for Lab 2. And we're going to learn some pretty cool stuff. Essentially, what's going on with Lab 2 is that we have these cylinders, more than one cylinder, and they're moving in a particular kind of action. Okay, so one goes out and then the other goes out and then one goes back and then the other goes back. I have a whole series of really powerful information about how to program that. So what am I talking about? This is purely pneumatic stuff, okay? So just like purely pneumatic. We're talking just the limit, just the cylinders, okay? 100%, just the cylinders and some valves and limit valves and stuff like that. I don't have a limit valve in my little kit here, but just this stuff. Like that's it. There's no electronics. We're going to program a circuit with just air. It's pretty cool. So we're actually going to put logic. We're going to add logic into a circuit that's just air, and it's really cool. So we're going to kind of learn a new programming language, and it's called the pneumatic sequential statement. It's very powerful. It allows you to actually build some really complicated kind of actions that these pneumatic cylinders can do without any electricity. So as you guys kind of have an idea, I mean, we're studying control systems. So you guys have an idea that, you know, if you use like a computer or a programmable logic controller or a bunch of relays or a bunch of like switches and cool configurations and stuff, we learned that in 110, we learned that, you know, you can add a lot of logic into stuff with relays and stuff, but we're not going to do that. We're going to study entirely doing that with just air. It's pretty cool. So let's just jump into the material here about the lab and stuff. And what we're going to do is we're going to talk about sequencing with positioning. So essentially, we're gonna control the sequencing with positions, like so how we know where the position of the cylinder is. We're going to get the information from what we call a limit valve, which is very much like a limit switch, except it's just air. It's just a valve. So let's jump in here. So here I am in week 2, and we're going to jump in here. There's a lot of material here. So this is really going to empower you, and it will be amazing. So just bear with me because there's a lot of stuff to learn. So just you know, go get some popcorn and hang out. So let's do it. What's going on here is that there's some this going through here, pardon me. There are some blank pneumatic valves, and you're going to use these to kind of do your rough drawings. And then also, we're going to study a lot of information in here. And this is what I'm talking about, this kind of language. It's a programming language, very much like a ladder diagram. It's a programming language that we can actually use to follow as an actual wiring diagram, or in this case, a hosing diagram. Okay, good. So here we go. Sequencing by position sensing. This is the actual lab, and then there's the submission of the lab work, which I will talk about in a minute, actually, probably in a few minutes. Okay, let's jump into the lab itself. Now, this is what's going on. I need you to go through this information, read all of this. Now, we're doing sequencing by position sensing. How do we sense the position? We sense the position with a limit valve and not a limit switch. Okay, so what's that all about? Well, what's going on is that we've got these different actions, and we're going to talk about two kinds of things. We're going to talk about a control statement and a sequential statement. So essentially, the control statement is this. If I had these cylinders, okay, so what's going on is that there's this description of an example of these cylinders that are going on, and I want to just focus on this. Essentially, what's going on is that a clamp extends, okay? So it clamps onto a part, and then a press extends and presses the part, or presses some attribute of the part. Now, this can be a lot of different things. We could be pressing a cake down. We could grab onto the cake and press it, or press something onto the cake in some kind of you know, cell that's actually, you know, building cakes in some kind of food processing. We could also be doing this in like a molding process for injection molding and stuff like that. We could do this in a lot of different ways. How about like you want to just hold onto a bottle in a beer capping station, and then just hit the bottle cap on and cap it. So there's a lot of, you know, applications for grabbing onto something and then applying force to it with another cylinder, and then removing that force and then letting it go again. So in this case, what's going on is a clamp extends, and then a press extends and presses it. The press then retracts, and then what's going on is the clamp retracts. So in this situation, we need two cylinders, and both cylinders have to extend and retract, and they have to do that kind of in a sequence, in a very specific sequence. So my C plus has to go out. Okay, that makes sense. And then my press, so I'm calling the cylinder for the press cylinder, P. I think that makes sense. It's good to have these, we can just give one symbol character to each cylinder. So my cylinder for clamping is called C, and my cylinder for press is called P. So I've got C plus, which is the extension of the C cylinder, and then I've got P plus, which is the extension of the press cylinder, and then after that I have P minus and then C minus. So how do I make all that work with no electronics, with just air? Well, we're going to discuss that, and this is actually really, really cool. So we have what's called a sequential statement. So in this case, we're designing, in this case, this is the control statement. As you can see, it says control statement right here. That's the control statement. Now, how do I actually hook all of this up and like make this all happen exactly like this? Without any electronics? Well, it's amazing, but we can do it just with pure pneumatics. This is called a sequential statement. Now, there's a whole chapter on this stuff, and we will go into this information. It's in this Blackboard. It's in Lab 2, so I'm not even going to go into this. I'm kind of skimming over everything right now, and then we're going to get into the kind of the meat of all of this. So what's going on is that in a sequential statement, we also have some cases where we have parallel actions. So it could be that C and P extend at the same time, and then C retracts, and then P retracts. And when we have parallel actions like that, we need something like this, where we put a bracket in. So in this case, this is another example. Now, I will go into this all in depth in another PowerPoint slide that we're going to look at in Lab 2. But for now, as far as Lab 2 goes, this is what it looks like. We've got two cylinders, cylinder A and cylinder B, okay? And then we're going to control how they move. And I've got 4 different options for you guys to control. So essentially, you're going to actually go into the lab and you're going to build a circuit that when you press a button, one cylinder will move, and then another cylinder will move, and another one, in some kind of sequence. Now, there are 4 different sequences here. You have to choose 2 of them. But I want you to choose at least one of them with the bracket, because I need you guys to get some practice doing these with brackets. So A and B will extend at the same time. Once they are fully extended, then A will retract and then B will retract. So what I need you guys to do is do either this one and this one, or this one or this one. So you have to do at least 2 of these. One of them has to be with the bracket. What you're going to do is you're going to go and you're going to design this with the sequential statement too, and I'll show you how to do that in a minute. But you're going to write down the control statement, and then on a piece of paper you're going to do the sequential statement, and I'll show you where that piece of paper is in a moment. And you're going to write the sequential statement, and then you're going to sketch the circuit, and I'll show you where you're going to sketch that circuit. And then you have to build the circuit in the lab, and you also have to submit an Automation Studio drawing. Okay, good. So let's move on with this. This is the procedure, okay? So now, when you physically do Lab 2, this is the stuff you have to do. So for each of the 2 circuits, whichever ones you choose, you have to design a control statement and a sequential statement. Again, I will show you where you're going to do that. And then for procedure 2, you have to do a hand drawing. This is actually all done on one piece of paper, or actually 2 pieces of paper. So, and I'll show you where that paper is. So the procedure is you're going to do a hand drawing and hosing on the blank schematics, and this is just a rough drawing, and that's fine. I will walk you through this. And then what you're going to have to do is you're going to physically go into the lab and build the 2 circuits that you've chosen. And then at the end, you're going to do procedure 4. You're going to do online lab work, Automation Studio drawing, and hand drawing. So what's going to happen is that I need you to do the Automation Studio drawings, and I need you to do the hand drawings. And again, I will walk through that as I'm showing you where that is on Blackboard. So let me just kind of do this. Let me pause for a second. For this procedure, this is the stuff you've got to hand in through Blackboard. You have to draw each circuit separately on Automation Studio, okay, and simulate them. By the way, all you have to do is draw one Automation Studio drawing, and then save it, and then open it again, and just make some changes. And then you can save it as a second drawing. Essentially, what you want to do is you want to go and open up your Lab 1, and you want to modify it, and then make Lab 2, pardon me, either this one, this one, this one, this one, and then save it, and then open it again, modify it, and do the other of the second one, and then save that and save it as a different file. So you've already done a lot of work in Lab 1, or you will do a lot of work in Lab 1 with your Automation Studio drawing, and just take that and modify it. Here we go. So if it looks good, that's fine. And if it works in your Automation Studio, you know it's working, and also you're going to test it in the lab, so you'll actually know that it works. Anyway, but draw it on Automation Studio, and then what you want to do is you want to put your BMO in your each drawing and include the border for each drawing, and there's a video on that. I'll show you where that is. And then if you haven't already watched it, and then add the date and all the information to your Automation Studio drawing, and then download the Automation Studio drawing from AppStream and then upload it. So okay, there you go. So now the hand drawing work as well is not in here. Where is it? Here. Here's the hand drawn work. This is the information of the hand drawn work. Okay, so Automation Studio, you get 5 marks for that. So you have to put all of this stuff in, and then you'll get 5 marks. Now, for the professional drawings, get this. This is actually probably a lot of work, and it's something that you may not be comfortable with because you're not used to it. But I really need you guys to get practice drawing stuff with your hands. So I need you to get a good pencil. I need you to get a circle template, and I'll show you what that means in a minute. And I need you to draw each of the circuits. So of the 2 circuits you've designed and drew on Automation Studio, I need you to draw them again by hand. If you want, you can actually take your Automation Studio drawing and, like, you know, maybe put it underneath your piece of paper, and then kind of mark off where all of the valves and stuff are going to go, and then draw everything. You know what? Just on your own, draw everything on your own with a pencil and a circle template. There should not be one single line or circle on your hand drawing that isn't drawn with a ruler. And look at all of this stuff here. So all lines must be a ruler or a circle template. All lines have to be parallel or perpendicular. No lines on an angle. Symbols have to be all correct. And then essentially what's going on is that it says professionalism. So you have to do it on a white or on a wit paper, okay? You know me with my fingers, I can't spell anything. So on a blank white paper, no lines, no graph paper. Don't do that. Just don't do that. Okay, let's continue. No smudges, no erased lines. So you really gonna think about how you're gonna draw this. You have to do some planning to make sure you do this properly. You can't erase stuff. And if you do erase stuff and I see it, or your lab instructor sees it, you know, you're gonna lose a mark. But if we don't see it, it's okay. So I might draw everything really lightly and then go over it again. Okay, and then put your name and your student number on it. So if you do all of these things by hand and you do that, you follow all of that, you'll get 5 marks for each drawing. And then submission instructions. You're going to actually submit these on Blackboard. So let's jump into Blackboard, and I'm going to show you all of this stuff. Looking at Blackboard. Here we go, Blackboard. So I'm going to tell you this guy, but we've been talking about submissions, so let's go to submissions. Okay, so when you do your hand drawing of circuit 1, whichever it is, there are 2 circuits, and you have to draw them. Once you draw them, I need you to scan them or take an image of them, and then just upload them here. And there you go. So, and you'll be able to submit that and submit that. Those are your 2 hand drawings. And again, they are done by hand with a ruler and a circle template. What's a circle template? Right here. If you don't have one of these, get it. Order from Amazon. You get it like right away. You need to have this. So, and you've got 2 weeks to do this. So as far as when the labs are due, I need you to like give yourself a week to hand it in. So the information, your lab should be handed in. All of the information for your lab should be handed in the week after you do it. So if you do it on a Tuesday, if your lab is on a Tuesday in week 3 or week 4, let's just go to week 5. Okay, week 5, you go into class on a Tuesday, your lab information should be done before your next class in the week. In week 6 of the Tuesday. Okay, good. So here you go. Here's a marking rubric for how you know how to, all of the information, all of the marks you get for your hand drawing. Here's the marking rubric for the Automation Studio drawing, and then you submit each of them here. And by the way, please do not submit some kind of PDF or a captured image. You have to actually submit the actual Automation Studio drawing. You know what? I'm just going to show you. I'm going to browse my files, and I'm going to go into Lab 2 over here. No, I'm going to go to here, wait, 153, and then I'm going to go to my labs, and then I'm going to go to Lab 3, and this is the Automation Studio drawing. You have to submit this. Please do not submit a PDF or an image. You have to submit the actual drawing. And you guys know how to get the drawing. off of AppStream onto your computer, onto your downloads, and then upload it to here. I mean, you know how to do that. So yeah, the actual automation studio you're on, so that we can run it when we see it and test it to make sure it works. Okay, good. So now you know what to do. You guys know, let me just go back here. You understand kind of the procedures of what you've got to do. You've got to read lab 2. You've got to choose 2 of those different control statements. And then you're going to do this. This is the first step. You're going to go into here. So this is a blank schematic with 2 cylinders. And this blank schematic with 2 cylinders of relay. You don't need to worry about this. Oh, is it? There's 2 of them? PNG, PDF. Oh, right. Okay, good. So what's going on is that you have 2 options. I'm going to open this one at first. Okay, I know it's sideways. That's fine. Print it out. And there's another option if you don't want to print it out. Write the control statement here. So the control statement, let me just go back to lab 2. Here we go. So you're going to choose, say, this control statement here. So B minus, A minus, B plus, A plus. Okay, good. So right here, you're going to write just in hand. It does not have to be pretty. This is just a work area for you to do your work. Write down B minus, A minus, B plus, A whatever. I forget the control statement. Write it down there. Then write your sequential statement in here. Now, don't even worry that you don't have any clue what I'm talking about when I say a sequential statement. Dude, we're totally going to get into that, like big time. Just believe me, you're going to write the sequential statement here. And then just you don't have to use a ruler. You don't have to, you can use a pen and scratch it out, whatever. Pencil's probably better. Just hose up this relay valve. Don't even look at it. It's not here. We'll talk about that later. So what you can do is you can run all of the hoses here. So essentially what you're going to have to do is, and I'll explain this in a minute, but you're going to have to draw an air supply there, air supply there, air supply there, air supply there. And you know what an air supply looks like. You're going to have to put an exhaust there, an exhaust there, an exhaust there, an exhaust there. And then you're going to take the air that comes out of here and you're going to put it into one of these pilots. So essentially, let's just say, so I know it's crooked, but just deal with it. Put your head sideways. Let's just say that B has to extend as soon as A extends. When A extends, this gets pressed down. We get air that comes out of here. I'm just going to put that air right into this pilot. Yeah, isn't that brilliant? And then this cylinder will just extend. So I'm going to show you this differently, and bear with me here. So that's the blank. So print that out and then draw the stuff by hand. If you want, you can also use this. I'm going to click on this guy, and I'm going to say, save image, and then whatever. I'm just going to save it, and it'll be in my downloads. Now I'm going to open it up. Now, you know me, I use Paint for everything. So here I am in Paint. Now let's just say you wanted to do this in a drawing program. So let's just say A plus B plus, what should I say? A plus, you know what I'm going to do? I'm just going to make this font super crazy big. Okay, here we go. Let me just go to like 150. There you go. 150. 150. Now that fits well. Okay, so this, let's just say we did this. A plus, B plus, and that's actually technically supposed to be a semicolon. B plus, semicolon, A minus, semicolon, B minus. Okay, that's my control statement. Now, what this sequential statement looks like is a whole different thing. Again, we can deal with that. So if you want to do this on a drawing program or Paint, I mean, Paint's so easy, right? You guys are used to using that from last semester, I think. Okay, good. So what I'm going to do is I'm going to pick a color, whatever. I'm just going to go for green so it stands out. So now, get this. You'll love this. I'm going to put an air supply here. Okay, and then I'm going to put my exhaust there. And then I'm going to put an air supply there. So if you really wanted to, I mean, you know me, I get pretty particular about things. So if you really wanted to, you could draw yourself own little air supply in here, and then just, you know, copy it and paste it. So I'm going to just actually do that. So I'm going to draw a line here, and then I'm going to erase this guy. I'm not even sure if this is the right size, but just play with it. And it's not even perfectly correct anyway. So whatever. So this is my little air supply. So now that's an exhaust, because you guys know that. So I'm just gonna copy it, and then I'm gonna go here, and then, I mean, this is probably more work than doing this by hand, but I'm saying if you want to do it this way, that's fine. So you can put your exhaust there. I'm just gonna do that. And then I'm going to paste here, and I'm going to put that exhaust there. And then here, I'm going to put that exhaust there. So essentially, just draw these by hand. Again, they don't have to be pretty. This is just for you for like kind of a working area. And draw that, and then draw air supply to this, and then air supply to all these valves. So now you've got air supply, and always also draw the air supply here and the exhausts here. Now, once you've done that, what are you going to do next? Well, and by the way, you got to put an exhaust down here too. So I want you to get used to doing all of that. Okay, good. So draw your air supplies and stuff like that. Again, do it by hand, do it on here. I don't care what drawing program you use. Now, what's going on here is that I'm actually going to just grab this brush. Again, it doesn't have to be pretty. Now watch this. After A extends, however we make A extend, I don't even want to talk about it. After A extends, B has to extend. Watch this. This is really brilliant. This is going to go to here. Let me make that thicker. That's just going to go to here. I mean, that's a hose. Essentially, that is a hose. I think that, makes sense. Now, watch this. After B extends, A has to retract. Watch this. You'll love this. When B extends, this will get pressed down. Air, because I've got air supply in here, right? My air supply is going in here. That it's going to come out here, and it's going to go into A minus. Watch this. Isn't that brilliant? Okay. Now, from there, what's going to happen is I am then, after A retracts, okay, so, right, A is going to retract, and then B is going to retract. So this information is going to go over to here, and it's going to, this is just a hose. This is just a hose. That is just a hose. That's just a hose. Now, after B extends, after B retracts, what's supposed to happen next? Well, do you know what? This whole thing is supposed to go around and around and around and around and around and around and around. And keep going as long as you have your finger on the button. Which button? The start button. Watch this. You'll love this. Out of B minus, I'm going to go out of B minus. Again, I have air going into B minus. I'm going to go this way, and I'm going to go all the way down here. I'm going to go all the way into this side of my start button. I'm going to go into this side of my start button. And now out of here, I'm going to go into A plus. Now we got a couple options here. If you draw this straight through this line, it's okay. Because if lines meet and we want to show that they're actually connected, if we want to show that a line is actually connected, what you're going to do is you're actually going to draw, just make sure my brush is on, it was on, but whatever, just silly. Then we're going to put a little dot there, right? So that indicates that they're connected. Oh, I just wanted to zoom out. Doesn't matter. That indicates that they're connected. So if you wanted to, you could just draw over it, or of course you can do this, and then you can do that. Either is acceptable. Okay, now watch this. Now, I know that I've got air in here, I've got my exhaust here, and all of this. Now, if I press this button, and this is the beauty part, if I press it and just press it just for a moment, and I let go of it, A will extend, B will extend, A will retract, and B will retract. It will all happen because as soon as I press this, this shuffles this valve over. So what happens is that the spool inside this valve moves over to the right, and air starts to go from here, and then this guy becomes active. Air is going to go out here, and it's going to go into this cylinder. The cylinder is going to move this way. The air that's in this cylinder is going to go out here, and it's going to leave. And guess what? Because this port, see, this goes straight through. This port is now connected to the exhaust. The air from this side will go out here, and it will come out. Now, the cylinder will extend. When I make this signal go away, because my button is only temporary, it's okay. The spool is moved. There's no spring that I have to hold on to. So what happens here is that when this extends, the air here will make this shuffle over here. Now this guy will stay in the position where he's been moved over here. This valve was moved over. It will stay there. There's no reason for it to move. So it will continue to make A extend, or at least trying to make A extend. When it goes out all the way, it will just stay there. You couldn't physically push it back because there's pressurized air going up here. Even though it's extended it all the way, that pressurized air is still there. So what's next is that when the air comes out of this, because when this gets pressed down, air comes out of here, it goes into here, it shuffles this valve over. This valve now is sending air out here, because this guy is now over here, and because this guy is in between here and here, the air coming out of here will do the same thing. So that's going to happen. Now, when it gets out, what's going to happen is that this information is going to come here and make A retract. And when A retracts, this information is going to go to here and make B retract, and then it'll just stop. But if I held my finger on this, it would just keep going and going and going and going and going and going. So that's pretty simple. So all you have to do is write your control statement, write your sequential statement, whatever that is, and then hose this stuff up just like this. Again, you can do this in this drawing program if you want. I don't care. I'm just going to close this and say no. And then what you can do is, or what you can do is you can use this guy and draw it by hand, and then take a picture of it or scan it, and then bring it to you with class. Bring it to you to the class. Bring it. Oh, I can't talk. Bring it with you to the class. So it's important that you do that before you go to class. So what we've learned so far in this is that you're going to read Lab 2. Okay, you're just going to read Lab 2. Now, all of that information in there at the first 2 pages, you can scan through that. It's okay, kind of like I did in my video just now, because an in-depth discussion of what this sequential statement stuff is actually in here, and it's to come. And all of this information is here. You can jump into it anytime you want. Now, what I'm saying here is that what you have, just kind of going through the procedure of what you got to do for Lab 2. The first thing you do is read Lab 2. Then you select whichever control statement you want to do. 2 of them, one of them has got to be with the brackets. Then what you do is you grab this thing, you open this up. You either open the PNG, you print it, and you do it by hand, or you draw it, whatever, and then you take that physically to class with you. So, oh, does that have to be done before your lab class? Yeah. Okay, so do that before your lab class. Don't not. Dude, if you go to your lab class without that done, you will be asked to leave. Well, that's so serious. Yeah, I mean, that's how serious it is. You have to have, you can't just walk into lab class and not have this done. Yeah, because then you won't be able to do the lab, because you'll be like, where do I hook all this stuff up? What do I do? Well, guess what? You know what to do because you just drew it. Okay, good. Well, I got a little excited. You know me. Now, good. So, then once you physically do your lab, you'll get a signature, okay, for that lab. Actually, your lab instructor will put a signature on their sheet. They won't come over and touch or sign any of your paperwork. And then from there, you have to go and draw it by hand and also do it by Automation Studio. But as I said earlier, do it in Automation Studio first. Check it, run it, make sure it works, and then go draw it all nice and pretty by hand, like really professional, like a draftsman drawing. Like if you have a drafting table, that's great. If you don't, go figure it out. You know what? And when you're doing your drawings, no kidding, get a bunch of paper. Okay, get a whole bunch of paper and actually do your drawing on a bunch of paper, and you will know, you probably know this already, but you will be able to actually print a lot better on that. Like, I don't know if you've ever seen a draftsman table. I remember building my own actually when I had to do drafting. Was cool, but there's this kind of like this green material on top that's really kind of soft, or not quite so, it's hard and soft at the same time, but you know, get a good background or whatever. Do you know what I do sometimes is I use this guy to draw on if I have to draw it real nice and pretty and stuff. Again, we want you, no, you can't do it with a drawing program. You have to do it by hand, because I want you to get practice to do this by hand. Okay, we're not done, because I've been avoiding this whole thing about what's this sequential statement thing. I'm going to go into that right now. Okay, good. So let's talk about sequential statements. And you're good, because so yeah, I just went over everything. You got to do, you read the lab, choose the 2 sequences you're going to do, print out the hand thing, the blank schematic, or do it on a drawing program and fill it all in, go into class, hook it up, get a mark for it, go home, and then you have to do your Automation Studio drawing and do it by hand. Now you can't do any of that without understanding what a sequential statement is. So let's jump into sequential statements, and I'm going to really empower you with this awesome knowledge of this programming language that's kind of like ladder logic in a cool way. So what's going on is that I'm just going to jump in here and I'm going to show you some examples. Now, there's an enormous amount of information here, and it's so important that you understand this stuff that there's even homework. You know what, it's called week 3 homework. It doesn't need to be week 3. I'm going to call it pneumatic sequential statements. Sequential statements, hand in homework. Done. Perfect. So now take a look at this. I need you guys to do this homework and practice all this stuff and learn how to do all of these things. You can't just jump into this and learn this stuff without really, you can't just go and just start to do this. You have to learn this because there are a lot of rules and regulations for it, but it's an extraordinarily powerful language. It's a programming language. Okay, so I'm just going to show you a couple examples here. So these example sheets are just examples. Again, this is the control statement. This is the sequential statement. Control statement, sequential statement. Is there one that we did for the A plus? Okay. This is similar to what we did. We did, I just discussed with you A plus, A minus, sorry, A plus, B plus, A minus, B minus. So this is similar. So what's going on is that these have conflict resolution. I don't want you to look at that. No conflict. I want you to look at this conflict stuff. No, just listen to me for a second here. There are two kinds of sequential statements, one with conflict and one without. Next week, we're going to do conflict. Right now, we're going to do no conflict. So I'm going to go into no conflict, and we can see these are all the rules and regulations. If you follow all of these, you cannot get it wrong. It's like the, bed mass for mathematics. Do your brackets first and then all of the other stuff. If you just, mathematics, you remember doing like basic math in grade 9 and grade 10 or grade 8. If you just follow a very specific formula, you cannot get it wrong. Sequential statements, same thing. Pneumatic sequential statements, just like this. There are all of these rules and regulations. So I'm not even going to go into these because I have extensive videos describing all of these. So this is me in my lab here in my home lab doing a lot of these really good examples. And this describes really intricately why sequential statements are powerful and what they can do. Now, sequential statements with conflict resolution, this is pretty cool. You can study this next week. What I need you to do study this week is study this stuff. Now, there's conflict resolution in here as well, but that's okay. Watch it. You can study this too and get ahead. It's fantastic. It's amazing information. And then what's going on here? There's homework here, and these are the solutions for the homework. So, by the way, I have to fix this. These are the actual solutions are in the homework. But I want you to mark yourself in this homework. So I'm actually going to find the actual file here that doesn't have the answers, because they both have the answers. I don't know what happened. So I'll fix that. So you can do the sequential statements, and then what I want you to do is I want you to give yourself your own marks. And the reason these marks are here is because marking rubrics are so powerful. They're such powerful tools to help you understand if you're doing it right. So what's going on is that you have to make sure that you follow all of these rules. And if you do, then you've got your sequential statement right. You can give yourself a 5. So I want you to mark yourself. Okay, so the homework has to also, when you hand it in, when I look at your homework, it better have actually marks. I need you to mark your own homework. So I'm going to fix this so that the actual answers aren't here. And then that'll be that. Now, as far as sequential statements go, what are they all about and stuff like that? There's a PowerPoint here. It's a great PowerPoint. Let's go over it. But I think what I'm going to do is I'm going to do a separate PowerPoint presentation just for sequential statements. So you can actually, at any time, you're like, what? You don't have to go back to this lecture. You can just jump in and do this PowerPoint. So I'm going to leave you with looking through all of this PowerPoint, which is really cool, and discussing why. So these are the sections you want to know. You want to know this guy, 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 and these. But then once you get into conflict resolution, I will do that later. Whoa, whatever. I'll do that later. So, because we'll do that next week. So for here, I need you to go through these PowerPoints and watch the video that I will do just on the PowerPoints. And then I want you to watch dude, this is fantastic. This is really good. These are some great examples.
From the relay valves. So right now, first thing I need to do is define the two groups.
So this is conflict resolution. Okay, so these all of the right, and because I did discuss that was conflict resolution. Now here, watch. You gotta watch. This is me in the lab. I'm having a lot of fun.
Locked. It's and they kind of cut the station, and he would press a button, and he would back off. The whole thing would have a boat. Yes, this is a really simple control.
Okay, so I'm talking about how to build the sequential statement and what it means and how how we actually draw all of these lines and what they actually mean. So, I mean, I've done so much work here describing this stuff. I don't want to go into it again. And once you get into brackets, dude, you have to understand what I'm doing with the brackets. It's absolutely crucial and essential that you watch this and understand how to do the brackets. So this video is actually not about conflict resolution. That's great. So this is perfect for lab 2. And here I am in my lab. And by the way, guys, when I did this, my throat was gone, so I'm kind of whispering. So you might have to crank the volume up, but there's some static.
You can see that from here. It's empty. Okay, well, it should work now, right? Let's go. Stop. Because there's another conflict. Check it out. Okay.
So it's me describing all of this stuff, and then I'm actually talking about what conflict is. So watch this stuff so you understand what conflict is, so that next week when we get into conflict, or the week in 2 weeks, well, whatever, when we start to talk about lab 3, you can understand what conflict is. So this is really talking about the power of sequential statements and how they work, how to actually draw them, and then there are a lot of examples here. This is the rules and regulation to deal with sequential statements. So in lab 2, what you're going to do is you are going to do all the stuff I just talked about, and you're going to go through here and looking at sequential statements and understand, watch these PowerPoints and stop at the conflict resolution. But if you want to continue on, and that's good, you can understand conflict resolution. This is me doing a video on sequential statements and how powerful they are, and then a little bit about where the conflict is there. And I will put another thing up here, and it's just like this. It looks just like this, although it discusses sequential statements with no conflict. And that's no conflict, and that has conflict. The conflict thing has a line there. Okay, good. So, all right, and the homework here. This is me walking through, showing you how to do the homework.
This guy is in action. Here, I should check that. You get A's with them crossing.
So I'm actually in that example. I'm actually just doing the homework, like right there. I'm actually doing the homework. That's homework and solutions, and then you have to hand in the homework here. So I want you to hand in the homework here, and you have to mark your own homework. So in here, you need to put a number in there.
And
you need to mark yourself.
have to.
And to do the marking, you just go through the marking rubric, which is at the top here. Go through the marking rubric and think about if you're going to get 5 marks. If you do that, you can't get those wrong. Okay, good. So you guys are good. Again, I'm going to post a video just going through this PowerPoint here, dealing with conflict. I'm going to do 2 PowerPoints. One is for sequential statements without conflict, and one is sequential statements with conflict. And I think we're good. I think that's all I have to say. And yeah, you guys are good. And you can email me or email your professors about this. So, or your lab instructors. And Dan is one lab instructor and Arturo is the other. And again, if you guys don't know who your lab instructor is or how to actually email your instructors, go to your schedule on my Humber. There's something called Week at a Glance. Go there and then go to any one of the classes and just click on the class, and it will open up the information on that class plus your instructor's emails. That's all I have to say, and that's it.